Hello everyone. In this couple of lectures, we're going to see some basic concept of mathematics and geometry. In particular, we're going to recall some basics of geometry, and we'll get to trigonometry, and we're going to solve some trigonometric equations and inequalities. Before doing that, let's recall the concept of functions. So, in mathematics, given two sets x and y, in x we have some elements, the same in y. A function is an object that, let's call it f, that assigns to each element of x one and only one element of y. Okay, this is a function. If I consider other two sets, let's call them again x and y, but this time I will do this thing. This is not a function anymore because this element is assigned to two elements of y. So this is not a function anymore. Okay, the next topic I want to recall you is the concept of Cartesian plane. Okay, I draw the Cartesian plane. These are the axes of the Cartesian plane, and we can define the Cartesian plane as all the points x and y, such that x belongs to R and y belongs to R. And I can define the Cartesian plane in this way. So, I can denote the Cartesian plane in 4 quadrants. This is the first, the second, the third, and the fourth. I can say that in the first quadrant I have x greater than 0 and y greater than 0. In the second one I have x less than 0 and y greater than 0. In the third one I have x less than 0 and y less than 0. In the fourth I have x greater than 0 and y less than 0. When I have x equal to 0 and y equal to 0, this is the origin of the Cartesian plane, and it's this point here. Okay, so let's draw a function in the Cartesian plane. If I draw the Cartesian plane here, I can draw a function, a generic function like this one. If I draw this thing, well, this is not a function anymore because let's recall the definition of a function. A function is an object that assigns to one element, each element of x, one and only one element of y. But let's consider this one, for example. This x star is assigned to more than one element of y. So this is not a function. Okay, so let's recall some basic concept of geometry, some basic function. The first one is the straight line. Okay, the straight line is, let's consider again the Cartesian plane. This is the straight line, and there's this equation. Y is equal to m times x plus b. Now, m is called the slope of the straight line, and b is the y-intercept. What does it mean? This b here is the point where the line intersects the y-axis, this one. This is the point 0, b. Okay? Let's consider 2 points, point 1, x1, y1, and p2, x2, y2. I can draw them here. This is x1, this is x2, y1, and y2. Okay. I can get this m, the slope of this line, with this formula, y2 minus y1 over x2 minus x1. Okay, so this is equal also to delta y over delta x. So I can express the slope of this line as this ratio. Given 2 points, in the plane, I can find the equation of the straight line as y minus y1 over y2 minus y1 equals to x minus x1 over x2 minus x1. Okay. Let's make an example. If I consider these 2 points, point 1 equals to minus 1, minus 1. P2 is equal to 1, 3. Let's draw it in the Cartesian plane. So minus 1 is here, minus 1 is here. So this is P1. And this is P2. So I can draw the line passing through these 2 points. Okay, I want to find the equation of this line in this way. Y is equal to mx plus b. So I have to find m and b. So in order to find these 2 numbers, we can use this formula. Y minus y1 is minus 1. Y2 minus y1 is 3 minus 3 minus 1. X minus x1 is minus 1 over x2 minus x1, that is 1 minus 1. Okay, so I can write it here. Y plus 1 over 4 equals to x plus 1 over 2. Let's move it here. Now I can just some basic maths. Okay, I will report it here. X plus 1 over 2. And this is equal to these things. I can simplify this expression, and I have y is equal to 2 times x plus 1. Okay. So we found this equation of the line. Let's check it. Point 1 was -1, -1. Point 2 was 1, 3. So how can we check this? Just by replacing the x and y coordinate in this equation. So y is, for point 1, y is -1 equals to 2 times x. So 2 times -1 plus 1. So -1 equals to -2 plus 1. As we can see, this is correct. Let's do the same also for point 2. Point 2, y is 3 equals to 2 times x, so 1 plus 1. 3 is equal to 3. And also this one is correct. Okay, let's move on. Let's see now the concept of parabola. A parabola is this one. Okay, how can we define the parabola? The parabola has this equation, y is equal to a times x squared plus b times x plus c. We can define the parabola as the sets of all points x, y in a plane that are equidistant from a fixed line, this one, that is called the directrix, and a fixed point here that is called focus. So I'm saying that if I take this point here, these two distances are equals. Now from the draw it's not true, but the definition is this one. So considering all these points, these distances has to be the same. This point is called the focus, and this one is the vertex. And the line passing through these 2 points is the axis of the parabola. If you consider this draw, this plot, the y-axis of the plane is the axis also of the parabola. I will report here some basic results that can be useful. The coordinates of the vertex are this one. The coordinates of the focus are this one. The axis is x equals to minus b over 2a, and as you can see is the coordinates of the x coordinates of v, so x equal to xv, and is also equal to xf. So also the x coordinate of the focus. We are saying that is this straight line, so the y-axis in this draw. I can write here also the equation of the directrix, that is this one. So it's an horizontal line. But what is delta here, here, and here? Delta is equal to b squared minus 4 times a times c. And this is the so-called discriminant. Okay? So, delta here, here, and here. Okay, let's move on. Okay, the next function is the hyperbola. I can write here the equation of the hyperbola, that is x minus xc over a to the power of 2 plus is equal to 1. What is xc and yc? These are the coordinates of the center of the parabola, of the hyperbola. It stands that if c is equal to the origin of the axis, the equation is simply this one. Okay, let's draw the hyperbola. These are the asymptotes of the hyperbola, and this is the hyperbola. And we can say that the hyperbola is the sets of all points that the difference of whose distances from two distinct fixed points that are, let's say, this one and this one, called foci, is a positive constant. So we can say, we can write it down here. If this condition is satisfied, the points belongs to an hyperbola. The graph of a hyperbola has two disconnected branches, and the line through the two foci, this one, is the axis of the hyperbola and intersects in the hyperbola in its two vertices. This is V1 and this is V2. We can also say that the asymptotes of the hyperbola passes through the vertices of a rectangle that is 2a by 2b, okay, and it's centered in the center of the hyperbola. Let's write down some fundamental results. V1 is equal to xc minus a, V2 is xc, sorry, this yc. These are the coordinates of the focus F1, so xc minus c, yc. What is this c? C is equal to the square root of a to the power of 2 plus b to the power of 2. Same thing for the focus F2. And the equations of the lines that are the asymptotes of this hyperbola, I can write here. Okay, this is the these are the two equations that describe the two asymptotes of the hyperbola. This one and this one. Okay. Let's move on the last concept we're going to recall, and this is the circle. Okay, my drawing skills are not the best, but this is a circle. Okay, the equation of the circle is this one. R is the distance from the center of the circle. So this is R. XC and YC are the coordinates of the center, and it stands that if C is equal to O, so the origin, XC and YC are equal to 0, so the equation of the circle is simply this one. So what is a circle? A circle is a set of all points in a plane that are equidistant from a point called center, that is this one. Okay, and the distance between any point of the circle and the center is called the radius, this one. The segment connecting two opposite points, like this one, is called the diameter. Okay, so if we consider, we are getting to trigonometry, if we consider the circle with this equation equals 1, this means that the radius is equal to 1. So this is R equals to 1. Let's write here the point P as xp, yp, and we can define the sine of alpha, where alpha is this angle. Okay, we can define the sine of alpha as yp over the segment OP. OP. This is the origin of the axis, but this segment is equal to 1, only this one. So the sine of alpha is simply yp. We can define the cosine of alpha as xp over the segment OP, but as before, this segment is equal to 1, so the cosine of alpha is xp. If we consider this equation, now we can write sine to the power of 2 of alpha plus cosine squared of alpha equals to 1. And this is the fundamental equation of trigonometry, this one. Let's also define the tangent of alpha as yp over xp and the cotangent of alpha as xp over yp. From this one we can see that the tangent of alpha is equal to sine of alpha over cosine of alpha, and the cotangent is equal to cosine of alpha over the sine of alpha. We can also write that the tangent of alpha is the reciprocal of the cotangent of alpha. Okay, but let's draw what is the tangent and the cotangent of the angle alpha. Let's consider again this circle. If I say that this is the point A and this is the point B, if I draw a straight line that passes through these 2 points, okay, I can say that considering this line, I call it A, and this line B, the tangent of alpha is equal to this segment. So it is the point where the line that goes from the origin to the point intersects the line A. So this is the tangent of alpha. If I consider the intersection with the other line, so I call this point T and this point C, the cotangent is this segment. Okay? I want you to notice that. Let's draw it cleaner. Again, the unit circle. If I consider this point P, I draw again the line, this is B, and this is the line A. This is the point P. The tangent of this angle alpha is the extension of the line in the opposite way. So this is the tangent of alpha. As before, the cotangent is this segment. Okay. Okay, so I consider this point P here. and this is alpha again. So this is the sine of alpha, and this is the cosine of alpha. I want to draw the graph of the sine considering alpha increasing in this way. So this is 1, this is minus 1. And I can draw it like this. Okay, this is 2 pi, this is 0, and this is pi. 0, pi, and we have also 2 pi here. So I'm drawing the graph of the sine with alpha that goes from 0 to 2 pi. From this point, from here, the sine repeats itself because it's a periodic function, and the period is equal to 2 pi. Let's do the same for the cosine. So I'm drawing the unit circle again. I have alpha here. So this is the sine of alpha, and this is the cosine of alpha. Considering the sine, when I have 0, alpha equal to 0, I have that the point P is 0. So sine of 0 is equal to 0. But if I consider alpha equals to 0, so this point here, well, the cosine is equal to 1. So the cosine starts from 1, and so on. As before, the cosine of alpha is periodic of period 2 pi. What else can we say about these functions? Well, as you can see, the two functions are shifted by a half pi. So these two functions are shifted by half pi. The sine, the function sine, is an odd function because f of x is equal to minus f of minus x. So sine of alpha is equal to minus sine of minus alpha. So if I consider the draw is like this one. So what I'm saying that is that the sine function is antisymmetric. The cosine instead is an even function. It means that the cosine of alpha is equal to the cosine of minus alpha. Okay, so this is odd and this is even. Let's do the same for the tangent and the cotangent. So let's draw again the unit circle. I'm drawing the line A, and the generic point P. This is the tangent of alpha. The function tangent is something like this one. Well, we have the asymptotes where the point P is approaching half pi, because if I'm increasing alpha, this segment is going towards infinity. So it's an increasing function right here. So this is an asymptote in half pi. I have here pi, and so on. What I can say about this function? Well, this function is odd because the tangent of alpha is equal to minus tangent of minus alpha. Let's do the same for the cotangent. Okay, I'm going to draw just the expansion of alpha, and is this one. The asymptotes now are in pi, and it's multiple. So I have 2 pi here, and so on. Same thing about the cotangent. The cotangent of alpha is equal to minus cotangent of minus alpha. So this function is odd as the tangent. Now, since trigonometric functions are periodic, we need to find an interval where the function is defined only once in order to invert it. So if I want, okay, let's say that y is equal to sine of x. If I want to get x, I can compute the arcsine of y. But what is the arcsine? Well, if this is the sine, I can invert it to get the arcsine, considering this part of the function. So this is 1, this is minus 1. I can say that the arcsine is this one, where we have minus half pi and we have half pi. So we are saying that the arcsine of x is a function that goes from range -1, 1, and has values in minus half pi, half pi. Okay, so let's do the same for the cosine. I can write x as the arc cosine of y. And I can do the same as before. So I'm going to restrict this function, the cosine, in an interval, this one in this case. And I get the arc cosine in this way. Where so what I'm saying is that the arc cosine is a function that goes from -1, 1 to 0, pi. Let's do it quickly for both tangent and cotangent. So I'm getting x as the arctangent of y, and I'm getting x as the arc cotangent of y. I'm going to draw just the arctangent, that is the restriction in this interval, and I have asymptotes in half pi and minus half pi. Okay. So I'm going to write right here. The domain and the codomain of this function, and the same for the arc cotangent, where here I have half pi, I have pi here, an asymptote in pi. So both the arctangent and the arccotangent has the domain in R. Let's go to the last topic. So let's consider again the unit circle. Let's consider a generic point P here. And this time I want to consider this right rectangle. Okay, all the triangle, sorry. All this triangle. So let's draw it here. It's a right triangle that I can draw it like here, where OP is equal to 1. The sign of alpha, following the previous definition, is this one. Same for the cosine of alpha. Now, so this is a triangle where we have 1 here. Let's consider a generic right triangle. So I'm going to draw it here. Okay, this is alpha, this is beta, and this is gamma. This is A, B, and C. From the previous results, we can say that the sine of beta is B over A. The cosine of beta is C over A. So what I'm saying is that I can write B as A times sine of beta. So B is equal to A times the sine of the opposite angle, this one, while C is equal to A times the cosine of the adjacent angle, beta. Okay. Okay, that's all for now. Let's take a break.